Good morning, student. In this video, we are going to discuss chapter 2, function and summation. We are going to discuss chapter 2, function and summation. First, we are going to discuss function. In the next video, we will discuss about summation. When we are studying foundation, we discussed and we defined about functions. And we said the meaning of function is nothing but f a to b such that f of a equal b, where a belongs to a and b belongs to b. We define the function like this. And then we defined what is the meaning of domain. Then we defined what is the meaning of codomain. Then we defined range. Even we defined about the types of function. We said that we are having one-to-one function. And we define about on-to function. For one-to-one function, we said f of a equal f of b if and only if a equal b. We said one-to-one function is nothing but f of a equal f of b if and only if a equal to b. For on-to function, we define like this: for all b belongs to b, there is an element a belongs to a such that f of a equal b. We define onto function as for all b belongs to b, there exists a belongs to a such that f of a equal b. Then we define the bijective function. We said the bijective function is nothing but the function which is both one-to-one and one and onto. We define all these ideas in foundation program. Here in this chapter, we are going to define two special functions which are required for computer data transfer, which are required for computer programming data management. Here, the first one we are going to define special function. The first one we are going to define floor. The meaning is nothing but the ground or bottom. And the second one is called ceiling, the top. We are going to represent the floor function in this way with small crayon. And ceiling we are going to define in the opposite to represent that we are going to take the upper values now. What is the meaning of this? What is the meaning of floor? I am going to take the largest integer. I am going to take the largest integer less than the given value x. The largest integer less than the given value x. The meaning of ceiling is nothing but the smallest integer greater than x. The smallest integer which is greater than x. When we define some problems, you can understand very easily what is the idea. For example, I am going to find what is the ceiling value of 7.1. That means I am going to find ceiling is nothing but the smallest integer greater than x. I am going to find the small integer which is greater than 7.1. Which is the nearest number which is greater than x? 7. This is nothing but 8. What about the ceiling of 7.9? Again, here we are not truncating it. We are finding the smallest integer which is greater than x, which is the big number, big integer than 7.9. Again, this is the same idea. We are going to check for floor. For example, I want to find the floor value of 7.1. That means I am going to find a small integer which is less than 7.1. What is this is 7. Is it the nearest integer? The same idea for 7.9 floor. Again, I am going to find the small integer. I am going to find the small integer which is the nearer to 7.9. Again, this is 7. So for ceiling, we are going to take the small value, and for ceiling, we are going to take the greatest value, the next number, the nearest integer, and for floor, we are going to take the smallest value. And you know that very well. In computer, the most important area is data management. The most important area is data management. Here in this chapter, we are going to discuss about the two ideas. One is called encoding. And the other one is called data transfer. We are going to discuss about encoding and we are going to discuss about data transfer. For encoding, we are going to use the ceiling function, and for data transfer, we are going to use the flow function. For encoding, we are going to use the ceiling function, and for transfer, we are going to use the flow function. And you know that very well. 1 byte is equal to 8 bits. Already you know that. 1 byte equal 8 bits. Using this idea, we are going to discuss some problem in this chapter. Using this idea, we are going to discuss some problem in this chapter. See, for example, how many bytes are required to encode 100 bits of data? How many bytes are required to encode 100 bits of data? See, for example, what is this? Here I know that very well. 1 byte equal 8 bits. I am going to write it the other way. 8 bits equal 1 byte. I am having 100 bits. I am going to convert them into byte. So 8 bits is equal to 1 byte. 100 bits is equal to 100 by 8. As we are encoding it, I am going to find the ceiling value of this bytes. So 100 by 8 is nothing but this is 12.5 ceiling bytes. That means I am going to find the nearest integer which is greater than 12.5. I am going to find the nearest integer which is greater than 12.5. So what will be the value? This is nothing but 13 bytes. This is nothing but the 13 bytes. So the basic idea, when I want to convert from bits to byte, I am going to divide the bits by 8, but I am going to find the ceiling value. I am going to find the ceiling value. This we can do for any number. See, for example, how many bytes are required to encode 1000 bits of data? The idea is same. Just I am changing only one number, 1001 bits. See, what will happen? 8 bits is equal to 1 byte. So 1001 bits equal. So this is 1001 divided by 8 ceiling bytes. So what will be the value of this? This is 125.1 ceiling. So 125, the nearest whole integer, near 125.1 is nothing but 126 bytes. So the basic idea, take the number bits, divide by 8 and find the nearest ceiling value. Nearest ceiling value. This is called encoding. This is called encoding.